Hello dear students, welcome back to NEET WORLD. So today we will be discussing class 12th 4 marks P block element questions. It means in the last sessions we have covered LAQ part, right? Now long answer type questions like 8 marks question for your first year IPE exams, right? So in this session we will be discussing SAQ questions. Okay, so even from few chapters like chemical bonding we already completed 4 marks questions, and then next after equilibrium and equilibrium also we have completed these 4 marks related questions. Okay, and then after we will be discussing P block elements today. So what we will be discussing here? P block elements. Okay, right, from these P block elements, yes, you can expect 4 marks questions and also 2 marks question. Okay, right now. So now we will be covering 4 marks first, then after in other session we will be doing 2 marks question also related to this P block. Okay, right, as of now. And again you can look at this material. This is a C60 material. It means this material is designed for all the IP students of Telangana and AP states, for both MPC and BPC, for first year and second year students. Okay, so now this material contains all the important questions of chemistry, okay, of this chemistry subject. Okay, so now this material is highly helpful if you are aiming to score 50 plus marks. Okay, yes, this is designed for 60 marks. Yes, I mean to score 60 out of 60. Yes, whoever preparing for IP, yes, you can utilize this material and you can access this material for free of cost. Okay, so now you can download this material from our NEET WORLD app. Okay, go to Play Store and download this material from this NEET WORLD app. Okay, just go to Play Store, then next download this NEET WORLD app. So in this NEET WORLD app, what you need to do is go to chat section and just say hi in the chat box. Okay, then our team will share you this IPE material for chemistry, physics. If you are an BPC students, you will be having biology along with physics, chemistry, and if you are an MPC, then next mathematics, physics, chemistry materials will be given to you for free of cost from our side. That will be provided in our NEET WORLD app only. Again guys, this material contains LAQs, SAQs, very short answer type questions, okay, along with the blueprint. Again, clear cut explanation of each and every question is provided. Okay, and explanation for that each and every question will be given in these live sessions of our NEET WORLD YouTube channel. Okay, yes, download from NEET WORLD app that materials and listen to our classes in our NEET WORLD YouTube channel. That's it. Okay, right, and if you have any confusions or any doubts, yes, you can write in the chat box for every live session. Yes, we will definitely consider for this. Whenever you are watching, if you have any doubts, just write in the chat box. We will be giving you the clear cut explanation for those doubts. Okay, here itself, right? Yeah, so this is how you can make your IP preparation more easier and score maximum marks. Okay, right, look at here. So if you look at these chapters, all these LAQs are done here. So we need to discuss this very short answer type questions and short answer type questions for IP, right? So here also today we will be discussing P block, then chemical bonding is over, right? Remaining chapters will also be discussed in the upcoming sessions. Okay, right. So now we will be explaining you P block elements 4 marks. Let me take that material first. Yeah, so guys, if you open the material, and look at these P block elements, yes, this is how you will be seeing. Okay, the first question here says explain the borax bead test with a suitable example. What they are asking? Explain the borax bead test with a suitable example. Okay, so now borax bead test is used for identification of basic radical. So what do we mean by basic radicals, acidic radicals? See, you know, we are doing salt analysis in our class 12th. In the next year you are going to do salt analysis. It means they will give some random salt, then unknown salt will be given. In the practicals you will be doing now, so you will be having 30 marks for chemistry practical right now. So for that what we will be doing, so they will be giving you some salt. Okay, so what type of salt, what is that salt, what is the name of that salt, what is the chemical formula of that salt, we should identify. Okay, so first of all, in order to get that, I will give you some basic connection between these basic radicals and salt analysis and everything. Just look at here. Whenever we are saying a salt, so for example NaCl is a salt. How this salt is coming? These salts are formed when a base and an acid is reacting, like NaOH and HCl. See, when NaOH is a base and HCl is an acid, when this NaOH, I mean Na plus and Cl minus combine to give a salt like this. okay, and along with this here OH minus H plus, you are going to get H2O, water as a thing here, okay. So now you got an NaCl now. So if you see in NaCl, Na plus is a cation and Cl minus is an anion, okay. So now Na plus, sodium cation coming from base now, so that's why we are saying this metal ions in the salt as a basic radicals, because these cations are coming from bases now, so that's why we are saying it as a basic radical. Similarly, chloride ion here, Cl minus ion coming from acid, so you can say acidic radical. Chloride ion is an acidic radical, like it is coming from HCl, so you can say acidic radical, okay. So now look at here, the borax bead test is used for identification of basic radicals, it means metal ions in the qualitative inorganic analysis. When we are doing salt analysis, so we can able to identify cations present in the salt using this borax bead test, okay. Now what type of cations, especially these transition metal cations are there now, like iron, cobalt, these compounds are there now, yes, that can be identified easily, because when the transition metal, for example cobalt is there, when cobalt is reacting with this, like upon treating with this borax bead test under heating condition, it will form a blue color bead, okay, that whatever the big blue color product formed, that indicates yes, the given salt contains cobalt cation, like that we will be doing, okay. First of all, let us understand the answer provided here, so that you can express this in your final exam also, okay. Let me explain first. So now see, the borax bead test is used for identification of basic radicals in qualitative inorganic analysis. Then next, what is the formula of borax? First of all, see, Na2B4O7 is a formula, like Na2B4O7 dot 10 H2O will be there. How many H2O? 10 H2O will be there. So now when you heat this molecule, when you heat this borax, what happens? It will undergoes dehydration, like whatever the water molecules you are seeing, all will be removed, so that you will get Na2B4O7 as a product here, okay. This is anhydrous form now, okay. Now upon heating this further, again I am heating further, so this will gives you B2O3. What is this? B2O3 dot NaBO3, okay, NaBO2, okay. So now what is the name of this reaction? Just look at here, when borax is heated, it loses water. See, whatever the steps we have made here, that is only theoretically written here. See, when borax is heated, it loses water and forms anhydrous sodium tetraborate. See, anhydrous sodium tetraborate is formed, yes, okay. Again on further heating, see, again further heating, this process is called fusion, okay. On further heating, it forms borax glass. Whatever the product formed here is considered as borax glass. What is this? Borax glass. So I will tell you, you can imagine what I am saying here. See, borax glass, just I will explain this using this pen, okay. Borax glass, which consists of sodium metaborate. Yes, this part is called sodium metaborate, and boric anhydride. This B2O3 is called boric anhydride. These are the two things containing the, right. Now what you need to take is, you need to take a platinum wire, like platinum loop you need to take, okay. So now you just take the platinum loop, consider this is a platinum loop, and what you are taking, so you are doing, you are taking this platinum loop and keeping in the borax salt, okay, like borax compound here, okay. Now you take it to the flame. Now what happens when you are keeping near to the flame? First of all, it will undergoes dehydration and forms this one. Again further heating gives this one, right now. So now what happens to your platinum loop? So at the end, wherever you have taken that borax now, so at that position you will be seeing a glassy type, transparent glassy bead is observed, okay. You are seeing like a glassy substance at the end, wherever you have taken that borax before heating, okay, right. Now this is what called borax glass, okay. Now to this borax glass, if we are adding our salt, what we are doing now, we are taking our salt. For example, the given salt contains cobalt, okay. So something like cobalt oxides, or so some salt will be there with some +2 oxidation state or something like that. Now what happens, our glassy substance here. From this boric anhydride is there now, so B2O3. So this B2O3 will react with this cobalt plus 2 ion and forms a colored bead. A colored product will be formed. Depending upon the color of the product, yes, we can estimate which type of metal it is, which metal it is, whether it is cobalt. Yes, if it is cobalt, it will give a blue color bead. Okay, if it is a iron, you will get a brown color bead. Okay, if it is a chromium, you are going to get a green color bead. I will tell you again. See, first what you are doing, you are heating, losing the water, then next again heating, you are getting a fusion product like a glassy substance, borax glass we can say. Now this borax glass is, look at here, boric anhydride. From the borax glass, you are treating borax glass, that boric anhydride is there in the borax glass, that will be reacting with our cobalt, so that you will get a cobalt metaborate. Okay, the bead formed here is blue in color. What is the color of this bead? Blue in color, due to formation of cobalt metaborate. The color of that bead is what? Blue color. Okay, now different metal oxides give different colors. Okay, so different metal oxides gives different colors. For example, you will get a green color bead when you are treating this with the chromium. You will get a blue color bead when you are treating with the cobalt. When you treat with the iron, you will get a brown color bead. Okay, so this is how, by looking at the color of the bead formed, we can identify what type of metal present here, what is the metal present in the salt. Okay, so that you can get a cationic identification, like basic radical identification and confirmation you got here. The next question is, how is diborane is prepared? What is the formula of diborane? First of all, B2H6. How this B2H6 is prepared? Explain its structure. Okay, we need to explain its structure and its preparation methods we need to discuss here. Okay, then next one more thing, if you study one more point extra, then you will get, it is useful for your EAP set. Preparation methods, structure and its properties, that's it. These are the things you need to look for your EAP set. Now here you are preparing already for your preparation methods of diborane, next structure of diborane, right now, right. Look at here. See, first method of preparation is boron trifluoride, from boron trifluoride like BF3. He treated with lithium aluminium hydride. So BF3 plus lithium aluminium hydride, when treated, it in dry ether gives diborane. So what is forming here? Diborane, B2H6 is formed. So what is the first reaction? So BF3 with lithium aluminium hydride. Okay, so here you take 4, here you take 3, therefore you will get a B2H6 type of compound. Okay, what you got? B2H6 you got. Okay, then next look at the other things here mentioned. The second method of preparation is from sodium borohydrate, that is NaBH4. So diborane is also prepared by oxidation of sodium borohydride with iodine. This is again important. Now they will ask a question in EAP set also. Which are the following method is useful for preparation of diborane? Okay, yes, they will mention some random reactions along with this exact reactions. Yes, these are correct examples for preparation of diborane right now. So now NaBH4 with iodine, what happens? Your iodine is converting into iodide ion. It is undergoing reduction and our NaBH4 undergoing oxidation and forming B2H6. So what is the reaction here involved? So oxidation of sodium borohydride with iodine gives diborane. Okay, remember this. Next, structure of diborane. What is the structure of diborane? See, nature of molecule and structure of diborane we will study here. Diborane is an electron deficient molecule. What I am saying? Diborane is an electron deficient molecule. So B2H6 is a electron deficient molecule. Okay, now it has 12 valency electrons instead of 14. See, normally if you write how the formula it is looking, B2H6 now. So if I want to write, if I am writing similar type of B2H6 means, if I write similar type of hydrocarbon, you will be writing C2H6. What is this C2H6 here? CH3, right now this is ethane. Okay, so instead having here in this case you have 14 electrons. If you count, there will be 14 electrons, but here if you count, there is only 12 electrons. It means 2 electrons are less now. So that's why we are saying is it has B2H6 as a electron deficient compound. See, there will be carbon, hydrogen, carbon, hydrogen, like this we will be having the bonds when you take ethane molecule, right now. So but this here if you observe in B2H6 this is not the scenario, the structure will be somewhat different. See here B is there, here also one more B2 is over, then next one more hydrogen over here and one more here, this side 2, and in between 2 borons we have 2 hydrogens, like this. Okay, so now if you see it has 12 valency electrons instead of 14. Okay, so how many valency electrons are there for this diboron? It is having only 12 instead of 14, which is required for 14 is a required electrons for normal covalent bonds. It means these are not normal covalent bonds, there is something different here when we compare with the ethane molecule. Okay, so what is the difference? Due to the 12 electrons only, due to its electron deficiency, this diboron forms 3-center 2 electron bonds. It means if you observe boron here, one more boron here and hydrogen in between. So for these 3 centers you have only 2 electrons. What we know, a bond contains 2 electrons right now. So if you look at these bonds, there will be 1 electron, here 1. So 2 electrons in a bond. But here there are 3 centers. Means here when you have only 2 centers you have 2 electrons. But here there are 3 centers, you have only 2 electrons. It means all these 2 bonds, whatever you are looking here, that contains only 3 electrons instead of 4 electrons. Generally one bond contains 2 electrons. There are 2 bonds means 4 electrons should be there. But what I am saying, between these 2 bonds there is only 3 electrons moving here and there. Okay, so now these bonds are called bridged bonds. What I am saying, these are called bridged bonds. Okay, remember, now bridged bonds also called as banana bonds, because if you look at the structure, see if I want to write the structure, I will be writing it like this: B, here one more B, hydrogen. See how many valence electrons are there in boron. If you write the boron electronic configuration, its atomic number is 5, so you are writing 1s2, 2s2, 2p1 right now. So valence electrons are 3 only on each boron, so you put 3 dots like this. Here also you put 3 dots. Done. Okay, one hydrogen this side, other hydrogen this side, here also hydrogen, hydrogen. And after this if you observe, there is only 1 electron here and one more vacant orbital with each of this boron. Okay, and 4 hydrogens over, next one more hydrogen I am writing here, each hydrogen is having 1 electron. So if you observe this, what you are seeing, see boron having only 1 electron on vacant orbital. So now what is happening here is, to this vacant orbital, see these electrons will be donated. So it means this together forming 1 bond and this together forming 1 bond. Okay, therefore you got a 3 centers, see 1, 2, 3 atoms, that's why in 3 nuclear centers now. So 3 centers are there, but how many electrons you are seeing? Only 2 electrons are seeing. So these 2 electrons are also shared with this boron and these 2 electrons are also shared with this boron. Okay, so there are 3 center 2 electron bonds. How many are there? There are 3 center 2 electron bonds are there. Just remember, this is also called as a tau bond, TAU, tau bond, are also called as banana bond. Okay, remember this. There are 4 terminal hydrogens, 2 are bridged hydrogens. Yes, these are 4 terminal hydrogens and between them we have 2 bridged hydrogens. Now look at here, each boron atom is sp3 hybridized. What is the hybridization of each boron in this diboron? It is sp3 hybridized. This is a question you need to remember. Okay, in EAP set also this is a question. See next, out of 4 hybrid orbitals, 3 are singly occupied and 1 is empty. It means on boron they are saying. Okay, 2 BH bridging bonds are normal covalent bonds. So these are normal covalent bonds only. Okay, the 2 bridging hydrogens form a 3 center 2 electron, that is 3 center 2 electron bonds, 1 electron from each boron and 1 from hydrogen. So 1 from boron and one from hydrogen, making a 3-center 2-electron bond. That is what they are writing here. Okay, these are also called as banana bonds or tau bonds. These bonds are also called as banana bonds or tau bonds. Okay, remember these points. I hope whatever the points, each and every point I have mentioned in the material is clearly explained here, right? Guys, if this explanation is clear, just click on the like button and you can access this material from our NEET WORLD app for free of cost. Okay, right. The next here, so this is how structure looks. This is how structure looks. Okay, so the next question, if you see, write an essay on preparation and chemical activities, chemical properties of diboron B2H6 they are saying. So what are the preparation methods we have seen? We need to treat lithium BF3 with lithium hydride or lithium aluminum hydride. Okay, you can treat with lithium hydride, you will get a B2H6. See, diboron is prepared by heating boron trifluoride with lithium hydride at about 450 Kelvin. So at what temperature? At 450 Kelvin if you heat, you will get a B2H6. Okay, now laboratory methods. Now how do you prepare? Taking boron trichloride BCl3 and lithium aluminum hydride. So in presence of dry ether, boron trichloride reacts with lithium aluminum hydride, forms diboron. Okay, so BCl3 with lithium aluminum hydride gives B2H6. Okay, this is what the product form. Okay, then next. Next one is boron trichloride and hydrogen gas are subjected to silent electric discharge, are passed over copper aluminum catalyst at 45 degrees Celsius. Then next you will get a diboron compound. See, BCl3 hydrogen gas passed in a silent electric discharge here. So what happens here? Catalyst used is like copper and aluminum at 45 degrees. You will get a B2H6 as a product. Okay, these preparation methods are must be mentioned during the exam, then only you will get good marks. Okay, then next, what are the chemical properties of diboron? See, what happens if we add water to the diboron? This is what the chemical reaction. See, diboron react with water to form boric acid and hydrogen gas is released. See, B2H6 plus H2O gives H3BO3. So H3BO3 is nothing but a boric acid, what we can call boric acid, and hydrogen gas is released, and they will ask what are the gases released during the preparation of diboron upon hydrolysis of diboron. Okay, or preparation of diboron also, here HCl gas is released. Like depending on the reaction, they will ask you the questions in your EAP set also along with your IPE. Okay, yeah, so my only intention is when you are preparing for your IPE exams, okay, try to understand the concept so that it will be useful for your EAP set also. Okay, see, if you just remember diboron upon hydrolysis, yes, we will get boric acid like orthoboric acid H3BO3 along with hydrogen gas. Okay, hydrogen gas is released here, you can remember. Hydrogen gas is liberated and boric acid is formed which is a weak acid. Boric acid is what? H3BO3 is a very weak acid. Okay, it's a very weak Lewis acid. What I am saying, it's a Lewis acid. Okay, then next, reaction with oxygen. When diboron is burned in air or oxygen, what I am saying, when diboron is burned in air or oxygen, it forms boric trioxide like boron trioxide B2O3 and water. Okay, what it is forming? See, when diboron is heated or burned in oxygen, it will be giving you B2O3 and water. Okay, and some amount of energy is released. How much amount? It is minus 200, then 6.4 kilojoule per mole amount of energy is released. So for 1 mole of B2H6, you are getting this much amount of energy. Okay, so diboron is highly flammable gas and burns with greenish flame. Okay, with what flame it is burning? It will be burning with a greenish flame. It is a highly flammable and the color of the flame is green. Okay, remember these 2 points. Yeah, guys, is this clear whatever we discussed till now? If there is any confusion, please let me know in the chat box. Next, this is also important reaction of diboron with ammonia. Okay, so when you are treating diboron with ammonia, it gives B2H6.2H2O. It forms ammoniate diborane. It means what? Two ammonia groups are there, like see, two NH3 groups are there with this diborane. Okay, B2H6 dot 2 NH3. Okay, right. So this B2H6 dot 2 NH3, whatever we have got here, further heating to 200 degrees Celsius. First of all, B2H6 with ammonia. So this together forming B2H6 dot 2 NH3. Okay, 2 NH3. This further heating, what happening? So further heating, it forms borazine. Okay, what it is forming? Borazine. So what is the formula of borazine? B3N3H6. This is what? B3N3H6 is the borazine, and hydrogen gas is released here. Okay, the gas released also very important. Try to balance the reaction and write it properly during the exam. Okay, so B3N3H6 is released. Okay, now if you want to write the structure, yes, it is really good if you write the structure. So what to do? So take 3 borons here like this. In between them you put nitrogen atoms in this way and attach them like this. And on each boron you put 1 hydrogen, and each nitrogen also 1 hydrogen. Like this you can insert. Now nitrogen contains lone pair electrons, boron contain vacant orbital right now. So into the vacant orbital of boron, nitrogen will donate their electrons. Okay, so it means here you will get a pi bond, here you will get a pi bond, and here you will get a pi bond. Like this you got a structure similar to our benzene. See, pi bond, sigma bond, again a pi bond, sigma bond, again a double bond, again a single bond, something like looks like a benzene now, like this only now, right. So now what it is indicating here? It is indicating that structure is resembling or similar to the benzene structure. And you know, borazine also called as inorganic benzene. What we can say? Borazine is also called as inorganic benzene. Here you can see borazine also called as inorganic benzene. Remember this. And then next, after this, what do you understand by allotrophy and inert pair effect, and the next catenation? So what are the meaning of this allotrophy, inert pair effect, all these things? So just look at here. So allotropy means it's a property of element. What I am saying, it's a property of an element to exist in 2 or more different physical forms but having similar chemical properties is called allotropy. So what do we mean by allotropy? See, like carbon will be in the form of graphite form, in the diamond form we are saying now. So these are carbons. Allotropes are what? We are saying graphite, diamond, these are different allotropes of carbon. Okay, so now how do they? The property of an element exists in 2 or more different physical properties but having similar chemical properties are called allotropes or allotropy. Okay, and you can give some examples here. So examples for carbon, you can say graphite and diamond, and you can say for oxygen you can say O2 form and ozone O3 form. These are the 2 allotropes of oxygen. Okay, then next look at here what they are saying here. Examples of carbon allotropes. Diamond, each carbon is bonded to 4 other forms a 3-dimensional crystal, the hardest natural substance known. Diamond is the hardest substance known, right? So how do the atoms arrange in that carbon, like diamond? Each carbon bond will be there. So around each of this carbon there will be 4 other carbons attached. Same scenario for all the carbons. Okay, now it will be having a very rigid structure here. So that is nothing but say very hardest substance here. Each carbon atom is bonded to 4 other carbons forming a 3-dimensional crystal. What it is forming? A 3-dimensional crystal which is the hardest natural substance known. And you know, you can remember for each carbon in diamond is sp3 hybridized. What is this? Each carbon in diamond is sp3 hybridized, and there is no free electrons to move now. There is no pi bond, only sigma bonds are there. There is no mobile electrons, weakly bonded electrons are not present. Okay, so it means it is a bad conductor. Okay, there is no electrons to move here and there, so it's a bad conductor also, you can remember. Diamond, I am talking about diamond. The next one we have is graphite. Next one we have is graphite. So graphite, if you see, each carbon is bonded to 3 others forming a flat hexagonal layer. Okay, so graphite is a good conductor. What they are saying, each carbon atom is bonded to 3 others, that makes a flat hexagonal layer. It means carbon, carbon, here one carbon, again one more carbon, like this you will get a hexagonal ring. Like this ring keep on going. See now what you can see, each carbon atom attached to other 3 carbons. Now this carbon is attached to another carbon. See 1, 2, 3. Okay, now there is a pi electron here. So due to the presence of this pi electrons in the hexagonal layers, so that due to the movement of that electrons, yes, we can say there is a possibility to undergo delocalization. Therefore, due to that reason, what happens, it can act as a good conductor. Okay, graphite can be a good conductor. Why it is a good conductor here? Due to presence of that pi electron movement. Okay, free electrons, pi electrons are there which are moved. Okay, due to that reason it is a good conductor. Remember this point. Okay. Next, one more thing here, what do we mean by inert pair effect? Okay, so inert pair effect means the tendency of an outermost ns electrons. What I am saying, the tendency of an outermost ns electrons of a heavy metal not to participate in bonding is called inert pair effect. What is that inert pair effect means? Yes guys, you know, same, these terms can together given as a 4 marks question, or each term will be given as a 2 marks question. This is a regularly asked question. Okay, that's why this question is very important, either for 4 marks, or if it is missing, then you can see this same question with the 1 or 2 names in the 2 marks question. Okay, so what do we mean by inert pair effect? Once again, the tendency of an outermost ns electrons of a heavier metal, a heavier element, not to take part in bond formation. It means, I will tell you, see here carbon family I am writing, carbon, silicon, germanium, tin, lead, like this we are writing. So down the group, as we move down the group, what happens, elements become heavier. So down elements, now what we can say, this down element, bottom elements are considered to be heavier. Okay, so now what is the general electronic configuration of carbon family? You can write ns2 np2, 4 valence electrons are there, that's why I am writing ns2 np2. So now np2, so total how many electrons are there? ns2 np2 means in the valency only 4 electrons are there right now. 4 here 2, 4 electrons are there. Now during the reactions, these 14th group elements can lose just these 2 electrons of p orbital, or they can lose all 4 electrons right now. So they can lose 2 electrons, or they can lose all 4 electrons right now. So for example, in the case of carbon, you can get a C plus 2 charge or C plus 4 charge. Both of them are possible. Okay, so as we go down the group, for these elements also that possibility is there, no? Yes, it is there. But the elements which are at the down, at this bottom, they won't, or they have less ability to show that higher oxidation state. It means they will be only losing this NP electrons. See, if NP, NS, both electrons, all 4 electrons, if we remove, it will get a plus 4 charge. But if you only remove 2, like p orbital electrons, you will get a plus 2 charge, no? So that is what happening in the case of lead. So in case of lead, we can only able to remove this p orbital electrons. Only p orbital electrons are removed. It will be showing plus 2. So it is very difficult to remove this ns electrons, cannot be given easily. Therefore it cannot form plus 4 oxidation state. Which one? Lead. So lead plus 2 is more stable when you compare with the plus 4. Yes, lead can form plus 4 also, but I am asking about the stability order. So which is more stable? Lead plus 2 charge is more stable when you compare with the lead with plus 4 charge. Why it is? Due to the concept of inert pair effect. Now again, why exactly, like what is happening here? Why these ns electrons are not participating in the chemical reactions here? Why it is not losing? Because if it go down the group, what happens here? You will be seeing f orbitals, like f electrons right now, d orbital electrons, and in between them we have inner transition elements, that is what, f orbital electrons, like that now. Okay, so due to the presence of that f orbital electrons, see its atomic number is very high, so nuclear forces will be very too much extent, like very greater extent of nuclear forces will be there. For example, I am saying this is a nucleus and these are the orbits. Okay. So now what happens here in this inside, we will be having in this inside level here, we will be having 4f electrons like that, let us say. So these 4f electrons are very poor shielding. It means they do not shield these outer electrons from the nuclear forces. Now what happens due to more positive charge? See, heavier element now, so it will be having more positive charge. So more positive charge will strongly bind these s orbital electrons. Okay, that ns orbital electrons very strongly binded by the nucleus. If it is very strongly bind by the nucleus, will it comes out? No, no. So that's why ns electrons are not coming out, only np electrons are given easily. That's why as we go down the group, lower oxidation state like +2 oxidation state is more stable compared with the +4. This concept is called inert pair effect. What is that concept called? Inert pair effect. So here I have mentioned everything in clearly. So just read this. The tendency of outermost ns electrons to take part in chemical bond formation, the tendency or the reluctance, see here you can see the tendency of outermost ns electrons of heavy metals not to participate in bonding is called inert pair effect, or in the other manner I can say the inertness or the reluctance of ns electrons to take part in bond formation or chemical reactions is called inert pair effect. Like this you can define. Okay, yes, this inert pair effect question is a most expected question for either 2 marks or for 4 marks. Okay, next time, due to poor shielding of d and f orbital electrons, ns pair electrons remains inert. They won't participate in the chemical bond because these ns electrons are strongly held by the nucleus of that atom. Okay, if this is nucleus is strongly holding, it will not be given to any other elements when it is undergoing any chemical reactions. Okay, so this is what the concept called inert pair effect. Okay, so lead shows +2 oxidation state instead of +4 due to inert pair effect. Okay, remember this. Okay, the next word is called catenation. Here what do we mean by catenation? See, carbon, if you see organic compounds, mainly organic compounds are made up of what? Only carbon and hydrogens. Mostly it will be having carbon and hydrogen, and along with this there are some other heteroatoms, but what you are seeing majorly big carbon chains will be there. Okay, right now. So this carbon is having ability to form very long chains right now, very carbon linkages right now, very long carbon linkages it is making. So what is the reason for it? So due to small size, the ability of an element to form long chains or rings by linking with its own atoms to the covalent bonds is called catenation. So now whatever the story I discussed, that is nothing but a catenation property. What do we mean by catenation property? It's a self-linking property. Means there are some elements like carbon, they have ability to link themselves. Okay, so due to the self-linkage property, they can make long chains or cyclic rings. Okay, so this concept is called catenation. See, the ability of an element to form long chains or rings by linking with its own atoms through a covalent bond is called catenation. What it is called? Catenation. Okay, the next here, see some examples are there. Carbon forms a long chains, rings and branch structures. Carbon has highest catenation tendency due to its high bond energy. So what is the reason for its high catenation property? That CC bond is there now. Yes, this CC bond is stronger and having energy around 348 kilojoule per mole. So this is a high energy. So due to its high energy and due to their similarity in sizes, same size now, and their small sizes, not only similarity, like their same atoms means same sizes will be there, and their size is very small. So due to small size, that overlapping of orbitals will be very greater extent, and that makes to be show a very good bond strength, and that is also reason for catenation property. Okay, and when it comes to silicon and sulfur, they can also show catenation but to a lower extent. Okay, so carbon family, as we move down the carbon family, what happens, that catenation tendency will be decreases, so that carbon will be having maximum catenation. Okay, so that's why if you see, carbon can form all four side bonds, like 4 sigma bonds, yeah, you can expand this ring, you can expand this chain, this chain, this chain. That's why we are seeing very big organic compounds in which carbon only the main framework maker here right now. So what is the reason? That concept called catenation. Okay, it's a self linkage property. The reason here is due to their high bond energy. Okay, right, remember these things. And the next here they will be asking, explain difference in the properties of diamond and graphite. What are the difference in the properties of diamond and graphite? So guys, those who are in the live session, just click on the like button if you really following the session. Yeah, look at here, explain the difference in the properties of diamond and graphite on the basis of their structure. So here you can say carbon exists in 2 allotropic forms, 2 crystalline forms. Okay, so what are those? Diamond and graphite. So both are allotropes of carbon but differ in the structure, bonding and properties. They have different structure because diamond we just now studied, it is having sp3 hybridization, graphite is having sp2 hybridization. Here all carbons, one carbon is surrounded by 4 other carbons through a sigma bonds. Now in case of diamond, in case of graphite, one carbon is surrounded by only 3 other carbons which has a hexagonal structure around it right now. So now here you can see what is the nature property. First one is nature. So it is a hardest natural substance. Diamond is a hardest natural substance. When it comes to graphite, it is a soft and slippery solid. So graphite is a soft and slippery solid. Okay, next structure is, it's a 3-dimensional rigid network. Diamond has a 3-dimensional rigid solid network here. Okay, when it comes to graphite, it's a 2-dimensional layered like structure. What I am saying, it's a 2-dimensional layer like structure. Okay, when it comes to hybridization, each carbon is sp3 hybridized. What I am saying, each carbon is sp3 hybridized. Okay, the next graphite is, each carbon is sp2 hybridized one. Okay, diamond is sp3, graphite is sp2. Okay, then next when it comes to bonding, each carbon is bonded to 4 other carbon atoms by strong covalent bonds. Which one? Diamond. Okay, when it comes to carbon, graphite, here each carbon is attached to 3 other carbons forming hexagonal rings. That's it, that whatever we discussed previously also, same story is there here. Arrangement, carbon atoms in diamond is arranged tetrahedrally. How they arrange? Tetrahedrally, like sp3 hybridization we discussed here. Okay, and carbon atoms arranged in a hexagonal sheets, like one sheet will be there and above that one more sheet will be there. Between them there will be some van der Waals forces. Due to that van der Waals forces, this graphite layers can have a sliding nature. So due to that sliding nature, the graphite can be applicable, or application of graphite as used as a lubricant. Due to this sliding nature of the graphite layers, it has an application as a lubricant. Which one? Graphite, not diamond, only graphite here. Okay, then next look at here, bond strength. These are, diamonds are strong covalent bonds throughout the structure. What I am saying, diamond has strong covalent bonds throughout the structures. When it comes to graphite, layers held by weak van der Waals forces. In graphite layers, how they are? Weak van der Waals forces are there. Those are holding these 2 layers in the graphite. Next, when it comes to bond angle, it is 109.5 degrees, or you can say 109 degrees 28 minute. What is the bond angle in diamond? This is 109 degree 28 minute. Okay, in diamond it is almost equals to 120 degrees. Okay, because it is sp2 hybridized, trigonal planar kind of geometry. Here it is a sp3 tetrahedral. This is the ideal bond angle in tetrahedral geometry. Okay, then next, what about bond length? You are seeing bond length here is carbon-carbon bond length in diamond is 1.54 angstroms and in graphite is 1.42 angstroms. Okay, right. Next, electrical conduction. Okay, conductivity. So graphite there is no free electrons, no, therefore in diamond there is no free electrons, no, therefore it's a bad conductor. Which one? Diamond. Okay, next, due to the presence of that pi electrons, that is nothing but free electrons that moves between the layers, that makes the graphite layer as a good conductor. Okay, it makes a good conductor. What are the uses? So used in cutting tools, drilling and jewelry. Okay, so where we can use diamond, it is used in cutting tools because it's a hardest substance now. Yes, this will be used for cutting of other compounds. Even diamond can be cut with the diamond itself. Okay, and the next drilling, and it is also used for jewelry purpose. Next, diamond is over. Next, graphite is used for lubricant, and the next it is an electrode. If you observe it in electrochemistry, in the next year you will be studying. Now you might be have studied about redox reactions. No? So in continuation to that, in the next year you will be studying, in the class 12 you will be studying electrochemistry. So where there you will be studying about inert electrode. Okay, so our graphite act as a inert electrode. Yes, we can use it as a inert electrode, and you can also use graphite in the pencil lids. So if you observe that pencil lid is nothing but our graphite rods only, like graphite lids only. Okay, that's it. This is what you need to know till now. Okay, then next, for IPE exam, these discussions you can use them effectively, whether you are BPC and MPC students. Yes, you can use this and utilize them very properly and make your preparation effective. Okay, not only chemistry, you can have physics as well as biology, mathematics, discussions, everyday live sessions are going on. So yes, you can join them and you can make it more effective. Look at here, what are electron deficient compounds? And the next are BCl3, SiCl4 are electron deficient species, and explain. If yes, then explain. So here see, electron deficient compounds means the central atom in that molecule will be electron deficient. It means less electrons are there. See, electron deficient compound is one in which central atom does not have a complete octet of electrons. Okay, it means there are fewer electrons, fewer than 8 electrons in their valency. If there is electrons less than 8, yes, we can say them as electron deficient species. Okay, such compounds tends to accept electrons to complete their octet, and therefore they are considered as Lewis acid. The best example I am writing BCl3. Okay, we know BCl3. We know boron contains valency electrons only 3. So what is the electronic configuration? Boron 5 atomic number. So you can write 1s2, 2s2, 2p1. Okay, so total are 5 electrons are there in it. So if I give 3 more electrons, it becomes like nearest noble gas. See, 5 are there. So still see, 5 are there. We know noble gas configuration here neon, no? So it means its atomic number is 10. So here only 5 are there. Still it requires 5 electrons to get that noble gas configuration. Or other ways, how many valence electrons are there here? You can just check here how many are there. Only 3 electrons are there now. You just insert the 3 electrons around the boron in this manner. Okay, so we know p orbitals will be 3. In p subshell there will be 3 p orbitals. S orbital already filled. Okay, now p orbital is having 1 electron only. So still how many we can accommodate? We can accommodate in 1 orbital 2 electrons, like that there can be still 5 more. Okay, 5 more electrons can be accommodated right now. So now you can see what this boron is doing. It is pairing up with chlorine atoms like this. So now how many electrons boron is having now in the molecule of BCl3? 1, 2, 3, 4, 5, 6. Why I am saying 6? Because in BCl3 1 electron is given by chlorine, 1 electron is given by boron for making this one bond, like 3 bonds, so 6 electrons. Now 6 electrons are over here, 2 electrons over, 3rd, 4th, 5th, 6th. You got one empty orbital here. So I am writing here that empty orbital. So if I give 2 more electrons, now what happens if I give 2 more electrons? Its octet will get fully filled. Therefore it get a neon gas configuration. So can I say BCl3 molecule is a Lewis acid or electron deficient? Yes. So this is having only 6 electrons. In order to fulfill its octet, that 8 electrons, in order to fulfill its octet 8 electron configuration, it required 2 more electrons. So I can say BCl3 as a Lewis acid or electron deficient species. Okay, right now. So now look at here, and like see, such compounds like BCl3 type of compounds tends to accept electron pair to complete their octet. and therefore they can act also considered as Lewis acid. Okay, these are the statements you can remember. Okay, the next BCl3, just now we have discussed, valence electrons of boron is 3, okay, and forms 3 covalent bonds with chlorine atoms, therefore 6 electrons it will be having. Now boron is in short of 2 electrons to complete its octet, therefore BCl3 acts as an electron deficient and behaves as a Lewis acid. Okay, it will be try to take a electron pair. For example, BCl3 here treated with ammonia, what is happening, just check here, ammonia contain non-bonding electrons, no? Yes, this is given into the empty orbital of boron in BCl3, so it is making a molecule like this, compound like this. Okay, so who donated this? Nitrogen of ammonia is donated right now. So the only one atom here, one molecule is giving pair of electrons to bond formation, no? So that kind of bond, the bond between BCl3 and NH3 is called coordinate covalent bond or a day 2 bond, you can say. Okay, remember this point also. Then next, one last question here, I mean discussion here, like example for SiCl4. SiCl4 here we have now. This is an electron deficient compound or not, they are asking. See, valency electrons of silicon are how many? 4. Silicon form 4 covalent bonds with 4 chlorine atoms. Okay, so silicon forms 4 valency electrons are there. Each valency electron of silicon is paired up with the chlorine like this. Okay, so it is making 4 bonds, so it has 8 electrons now. See, silicon form 4 covalent bonds with 4 chlorine atoms. The total electrons around the silicon are 8. So 8 means completely octet fully filled now. Hence CiCl4 is not an electron deficient. What we are saying, it is not an electron deficient. It is electron precise. It means precise means yes, it has a required number of electrons. Now there are 3 terms I am saying. One is deficient, electron precise, electron rich. So electron rich means there are some species having more electrons in it, then that will be considered as electron rich species. And precise means only 8 electrons are there, na? Yes, this can be considered as electron precise. It has exactly 8 electrons around the central atom, then you can consider it as electron precise. If more than this, electron rich. If less than that, electron deficient, poor, electron deficient. Like that you can have the examples. Okay, now they will ask what is the difference between electron deficient, electron rich and electron precise compounds, or give some examples. Like that they will ask based on this discussion. Yes, I hope you can now ready to answer this kind of questions. So these are the 4 marks questions from your P block elements. Okay, so the complete discussion of SAQ questions that are must be focused for your IPE exams are clearly discussed here, and if you have any confusions in understanding from this discussion, please write in the chat box. We will be discussed then in the upcoming sessions. Okay, so thanks for watching. Please share these sessions with the those students, whether it might be your friends or juniors, seniors who are preparing for IPE exams. And guys, we are also making videos for EAP set also in continuation to this. Okay, so the live sessions are going for them separately. You can join those live sessions also. Now for example, chemistry morning session I will be taking IPE live session, and at evening 5 p.m. will be 5:30 p.m. I will be taking EAP set live sessions. You can join them and also you can utilize them perfectly and make your preparation more productive and more effective for upcoming EAP set exam also. Okay, even if you are class 11th, yes, you can start your preparation for your EAP set from now in itself, and these sessions are also helpful for your NEET JEE preparations also. Okay, so thanks for watching. Stay connected with us. Thank you.